This is the example 1 on page 1029. Okay, so negative 25x squared minus 4y squared plus 100x plus 16y plus 20 equals 0. So this is a clean cut. Yes. Perfect. Okay, so I see here a term with x squared and a term with x. I also see a term with y and a term y squared and a term with y. So I have to look at these two terms. And first I will factor out negative 25. So negative 25, and this is x squared and minus 4x. Would you agree so far? So from negative 25x squared and positive 100x, I factor out negative 25. You will try to get back in, and you get positive 100x. The middle coefficient is negative 4. We divide it by 2. We square that number, and then we have to add 4 and subtract 4, which is 0. In the same way, we will factor negative 4 from these two terms. So negative 4, and then we have y squared minus 4y. And again, the same positive 4 and minus 4. Still 0. Plus 20 equals 0. Next, I have negative 25. I will group these and change into x minus 2, everything squared, and leave the negative 4 alone. Same thing with negative 4, and we have y minus 2, everything squared, and minus 4, and plus 20 equals 0. Now I have to distribute negative 25 outside, not inside, of course, of the square. And negative 25 to negative 4, and negative 4 to negative 4, and the other one. What I recommend is, when we move 20 to the other side, everything becomes negative. So I'm going to multiply by negative 1 to eliminate all those negatives. X minus 2 squared minus 4 plus 4, y minus 2 squared minus 4. It would have been negative 20, but now it's going to be positive 20. All terms were negative. This was negative, and 20 on the other side would have been negative. So I multiplied everything by negative 1. I can already say what this is. Can anyone say what this is? What we expect it to be? Since everything is positive, I'm assuming I can make a 1 here. We'll see. We'll see. I will still have negative 25 times negative 4. We'll see in a moment. Okay, so 25 x minus 2 squared minus 100 plus 4 y minus 2 squared and minus 16 equals 20. And yes, indeed, all terms will be positive. Which situation is that? When all terms are positive. I never have to worry about negative. So this is 136. Okay, we don't know. We will divide everything by. Very good. X minus 2 squared over 136 over 25 plus y minus 2 squared over 136 over 4 equals 1. Now we know for sure that this is an ellipse with a center at 2, 2. Now, depending on which one is bigger. Is 136 over 25 bigger? No. Is 136 over 4 bigger? Yes. So this is bigger, and it's under y. So it will be on the major axis will be a vertical axis. Any questions? Any questions on this? Do we know how to complete the square and determine what it is? Is that a yes? Is that a no? Okay, so let's suppose now we are asked to determine the vertices. We have the center. But let's say we're also asked to determine F1 and F2, the two foci. So what about this? How high would it be? It will be, first of all, on the same axis with the center. That's mandatory. No question there. But how high will it be? It will be 2, which is the y-coordinate of the center, plus the square root of 136 over 4. So this will be this piece, 2 plus the square root of 136 over 4. What will this be? Well, 2, which is the y-coordinate of the center, but minus the square root of 136 over 4. Do we understand?
What the P was supposed to be?
P is only for parabolas. Thank you for asking. P is only for parabolas. If the parabola opens upward, P is a horizontal, the directrix horizontal line. If it opens to your right, it's a vertical line past the vertex. So the directrix is characteristic to parabolas only, not to ellipse or hyperbola or circle. How do we determine the coordinates of the foci? Okay, first of all, F1 must have the same x2, and F2 must have the same x. So all of them, the vertices, and of course I should determine these vertices as well. So the vertices, it's a vertical ellipse, the center and the foci all have to be on the same axis. They all have x equals 2. Now we have to determine what? But I have to determine the lowercase c. So remember, c squared equals a squared minus b squared. This must be the bigger of the two. So it must be 136 over 4 minus 136 over 25. So c will be the square root of this. I don't want to spend time just calculating these numbers. I just want to give you the calculation. So what will this be then? From the y-coordinate of the center, up c. So it's 2 plus c. From the y-coordinate of the center, down c. 2 minus c. This little c. Right? This number. Now let's look at it, a parabola. It's a good idea. And then I like to look at sequences. So let's look at the parabola. Any questions?
Yeah, how did you know whether to use for finding the
Yes?
the maximum is there?
How do I know?
Yeah, because you use
You
square
mean-
root of 136 over 4 versus.
You mean this coordinates?
Yeah, you use 136 over 4, square root of that instead of the square root of 136 over 25. So how do you know which to differentiate?
Okay. So if you have 136 and you divide it by 25 people, or you have 136 and you divide it by 4, which of these two would be more? Right. So that is bigger. Because it's bigger and it's under y, it means that it's a vertical. The axis of the ellipse is bigger. It's a vertical. Sorry. So then from the center, it's a very good question actually. So from the center, which is 2, 2, this piece has to be the square root of that. And this piece has to be also the square root of that. But from the y coordinate, which is 2, up 1/36/4, or down 1/36/4 will give us the coordinates of this point. I was too lazy to calculate. I mean, I can't.
So if you just want to do the 2 points that are
On the other side.
right, then you would use
Yes,
yeah.
yes, I have to. So the coordinates of this point, first of all, they are all on the y equals 2. They have to be on the same axis, horizontal axis with the center. So now this piece will be 2 minus the square root of that, and this here will be 2 plus the square root of that. Very good question. Is that clear? Thank you. Yes, please.
So in case if we have A equal to B, like A and B, are
If A and B are equal, it's a circle.
then we don't need to find C, right?
Then you don't need to find C because it doesn't have foci. I mean, you can, but it's going to be 0. Yes, yes. Very good question. Very good question. Let's make up a parabola. Let's take a look. Let's say we have y minus 3 or y plus 3 squared equals 8 x minus 2. So is this a parabola? Yes, it is. Thank you. Yes, it is a parabola. Can anyone give us the vertex? So when it comes to parabolas, we do not talk about vertex. We do not talk about center of the parabola, but the vertex of the parabola. It has no center. Hyperbola, ellipse, and the circle have center, but the parabola has a vertex. Can anyone give us the vertex of this parabola?
2 and A.
Excellent, awesome. So now this number in front, 8 equals 4p, which means p equals 2. Okay. So I'm going to start graphing it already. So 2, -3. This is the point. This is the vertex. I already know it's not a function. And this must be y equals -3 axis of symmetry. I immediately know that. On this axis of symmetry, I will also find the focus of the parabola.
How do you
Now-
know that there's a y-intercept? Or sorry, how do you know there's a y-asymptote right there?
Okay, it's not
Or
an
is it not
asymptote.
asymptote?
It's axisymmetric. Okay,
Yeah.
so if the parabola opens upward, it has a vertical axis of symmetry.
How do you know it's only upward at this point? Because
Very good question, because I have y squared, not x squared.
Right.
Y squared is not a function. Every time I see y squared, it's not a function. It's either this or this, but not a function for sure.
So if it was x plus whatever, it would go like this or like this.
What do you mean by x plus whatever?
Like if you switch it like the x's and the y's, then it would.
Yes, if I have x squared and just plain y, it's either this or this. But if I have y squared, it's either this or this. So if it opens either to your left or to your right, I think I said it the opposite, either to your right or to your left, it must have a horizontal axis of symmetry. Because all parabolas like this have a vertical axis of symmetry, either opening upward or downward, it doesn't matter. So once I found the vertex, and I know that it's a conic section basically, not a function, then I know that this is the axis of symmetry, and on the same axis, I have to find the focus. I don't know where the focus is. In a minute, we will. But it has to have the same y coordinate, -3. We will see which x coordinate in a minute. Okay, so P equals 2. So from the vertex of the parabola, 2 units, well, it happens to be just the y-axis. So this, it's an overkill. So x equals 2. Which means that the focus must be 2 units away as well. I made it too much. So right here. So if this is 2 units, this must be the distance between the vertex and the focus must be also 2 units. So now I have the coordinates of the focus. What will be the x coordinate of the focus? 4. What will be the y? For sure, carved in stone. -3 indeed. Now, this is good. I have the directrix, I have everything, I have the focus, I have the vertex, but I want to graph it. But I need 2 points to graph it. So for example, let's pick something. You either pick x or you pick y. So if we want to pick x, you have to pick x starting from 2 to the right. Because for example, if you pick 0, you're in trouble. You get something squared equals a negative number, impossible. So pick a number for x, whatever you want, not too far out, and determine 2 points so we can draw the parabola. So something that we could, if possible, that we could take a square root from. So here's what I would like to plug in. I would like to plug in 4, because 4 minus 2 is 2, and 2 times 8 is 16, and I can take square roots from both sides. That's what I want. So I'm going to say that x is 4, and then y plus 3 squared equals 16, which is nice. Because when I take the square root, I get y plus 3 equals plus or minus 4, or y equals -3 plus or minus 4, and I get 2 solutions. So I get 4 comma -7, and I get 4 comma -1. That's all I want. So 3, 4, 5, 6, 7. And 4 comma -1. I don't like something. They have to be symmetric. They have to be symmetric with respect to the axis of symmetry. So what did I do? 3, 4, 5, 6, 7. Right? And the other one is -1. Yeah, okay, thank you. See, I realized immediately they have to be symmetric. If they're not symmetric, the points, I know something is terribly wrong. So it is 1, thank you. So making sure, is this 4 units? Yes, is this 4 units? Yes, okay, now it works. Thank you very much. And that's it. You understand that all points have to be symmetric with respect to the axis of symmetry. One of them cannot be 5 units away from the axis of symmetry and the other one 3. It's not possible. You can fold the parabola with respect to the axis of symmetry. Okay, how are we doing so far? Any questions for me? Please.
Just really quick.
Yes.
You have that axis labeled x equals 2, so that.
That is the directrix.
Okay.
So the focus is at 2 units away, and also 2 units away is the directrix. We determine this distance from this,
Okay.
because we were told that x is 2. The p is 2. If p is 2, then the directrix will be found 2 units away from the vertex, and that gives us 2 units away from the vertex on the other side, the focus.
Okay. So is that line x equals?
Yes, this is the directrix. X equals.
But shouldn't that line be x equals 0?
X equals 0.
Oh, yes, of course.
Yes. Okay.
Of course. Absolutely. And that's what I said, is the y-axis, but I wrote 2 instead of 0. Of course, thank you. Yes.
So is there any formula to determine this focus? Like the other coordinate of the focus.
Yes. It's the P. Yes. It's 0, comma P if the vertex is at the origin. But in this case, it cannot be 0, comma P because it's a shifted conic section. It's a shifted problem.
So in this situation, we have to add P with the other coordinate, like the x and y, whatever the case is.
Yeah, so that's why we had 4 here. And the vertex was 2, comma negative 3.
Well, since you have to add P to the vertex, and then you have to subtract P from the vertex in order to get the 2 points.
No, it's because we had P which was 2. So if this is 2 units, so see. So what was the question again? Maybe I misunderstood the question.
Like, you're wondering how to get the 2. Okay, right?
Say it again.
Like in like what was
The ellipse.
the ellipse?
Okay.
Like c square equal to a square plus b square.
Right.
Is there any way we can find something here that we can add and subtract to get this focus?
It's just 0, comma P.
Oh.
But because the vertex is not at 0, 0. The vertex is not at 0, 0. That's how we get that 4. We're adding the P to it.
Okay.
Yes. To the vertex, I'm adding the P.
And the other part of the coordinate will remain same.
Yes.
Okay.
All of them have to be on the axis of symmetry.
Okay.
I shouldn't say all of them, 2 in this case. The vertex and the focus have to be on the same axis, and they will be on the axis of symmetry, regardless of whether it opens up. So the vertex and the focus, they have to be on the same vertical.
And what determines like it will open this way and the other way?
Yes, it doesn't open the other way because you have everything is positive. Otherwise, very good question. So here's the idea. If I have, let me copy, it was y plus 3 everything squared equals 8x minus 2, correct? So only if in this situation, in which 4p equals negative 8 and p will be negative 2, the parabola will open the other way. Why? Because this has to be negative at all times. This quantity has to be negative, so that negative times negative is positive, because this is always positive. So x has to be to the other side. So all these values must be negative at all times. So that when we multiply by negative p, we always get a positive number.
And what will be the focus in this case?
So I have to graph it. So the vertex in this case is still 2, comma negative 3, right? Very good question. Excellent. So the vertex is still 2, comma negative 3. The axis of symmetry is still the same. P is negative 2. So it means that x equals 4. So this is the distance of P, which is 2. And then I have to go this way 2 units. So this will be the focus. So then the focus of this parabola will be x is 0, y is negative 3. So this distance still has to be the same. And now the parabola will look like this. Better? So that is the issue. This will be always positive. If this quantity is negative, then this must be negative at any point in time. Whatever x is, you cannot plug in here 10. It won't work. 10 minus 2 is 8. 8 times negative 8 is negative 64. Not possible. This is not a point on this parabola, because a positive number cannot equal negative 64. So all your x values have to be here, between positive 2 and negative infinity and positive 2. So that this quantity will always stay negative because of the negative in front. Does it make sense? Okay, yes, Connor, you had something? You wanted to say something?
Oh,
No, I did. On the above example again, I noticed you had, you wrote the dotted line with x equals 2 and then you changed it to 0. Was that the directrix?
Oh, yes, it is a directrix. Yes, so the directrix is the y-axis. Why I wrote x equals 2, I don't know. I just even said it's an overkill. It's x equals 0, but I wrote 2. My apologies. I didn't mean it. Good, other questions? Yes, please.
Can we try my tabular question?
Oh, say it again?
Can we try?
Yes, after we finish the sequences, because I'm down to 15 minutes, so I want to look at few sequences. For example, what if I were given a sub n equals 3, a sub n minus 1? Any questions? A sub n minus 1 and plus 2 for n greater than or equal to 2. We're asked to determine the first 4 terms. So we will determine, we have to be given A1. So A1 is, let's say, 3. How do I determine A2, A3, and A4? A2 will be 3 times 3 plus 2. So this is 8. A3 will be 3 times 8 plus 2, and so on and so forth. Yes, please.
That's a sub n minus 1, or is it plus?
No, minus. A sub n minus 1, sorry about that. Okay, so let's determine the generic term of something like 1/2, 1/3, 1/4. We want to determine a sub n. What will you write? So that would be 1 over n plus 1. When n is 1, I have 1/2. When n is 2, I have 1/3. When n is 3, I have 1/4, and so on and so forth.
What's your full person? How do you tackle this question?
She, okay, when I saw her do, she said, I was like, how did you do that? She just plugged in A2 and for A then.
You mean for this? Yes. So I determine, so 3 times 3 is 6 plus 2 is 8. And then I have 3 times 8 plus 2. So that's 24 plus 2 is 26. And then 3 times 26 plus 2, and I can continue forever. Because that's what the recursive formula is telling us. Any term is multiplied, is obtained by multiplying the previous term by 3 and added 2. So the previous term multiplied by 3 and adding 2, the previous term multiplied by 3 and adding 2, the previous term multiplied by 3 and adding 2. That's what the pattern is telling us.
So she used A2 first.
Is that okay?
Is that terms of this?
Did I answer your question?
Yes, but for the next one,
Yes?
like how do
I
you
just look at the
tackle-
pattern, nothing specific. I just look at the pattern. I see that all of them have 1 at the top. The generic term has to have 1 at the top. And how do I get a pattern for the denominator? I said n plus 1, and then I check. When n is 1, I get 2. When n is 2, I get 3, and so on and so forth. It's not, I don't have a particular recipe. It's a very good question. Excellent question. I don't have, yes, please, Connor?
For a problem like this, if
Yes.
we're given it on a test,
Yes.
how far would you like us to go? Or we just
You don't have to, no, this will be given to you. You only have to determine this. You're asked to find the general term. It's a very good question. Sorry about that. I thought you already looked at these problems. So here, I'm giving the pattern. All I'm asked to find is the general term.
Could you give it another example?
I'm sorry?
Could you give it another example?
Sure. Let me see if I, I'm sorry? This is a sub n, the general term.
No, on the previous question.
How we got this?
The first A2. How did you?
3 times the previous one plus 2. 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 That's what the pattern is telling us. 3 times the previous term of the sequence plus 2.
Yeah, just look like 9 plus 2.
We are given this. This is given.
Yeah.
This is given to us. 1 second. Is this okay?
I mean, it looks like 9 plus 2 to me, so how's that 8?
Oh. Now I see what he's asking.
Okay, so all else.
I don't know.
Good.
I'm trying to finish. No excuse. Okay, I got it now. 33 plus 2, 35. I got it. Sorry. So this is it 105 plus 2? 105 plus 2, is it 107? Sorry about that. I didn't mean that. I'm just trying to go through everything. So you have examples from everything. So we want to see another example of a sequence. So let's take a look. Good question. If you have one from WebAssign, give it to me, please. Okay, I got it. So let's say negative 2 over 11, 3 over 13, negative 4 over 15, 5 over 17, negative 6 over 19, ... And we're asked to find a sub n. Okay, so let's see what happens with the denominator. These are all, if you see odd numbers, 11, 13, 15, 17, 19. So we have several ways of coming up with the odd numbers. One of them would be like 2n plus 9 because we are starting at 11. It's normally 2n plus 1 as an odd number. But because we are starting at 11. So let's see. When n is 1, 11. When n is 2, 4 plus 9. When n is 3, 6 plus 9. I'm trying not to make errors now when I multiply. When n is 4, I get 17, and so on and so forth. Yes. And now let's see what we have with the top. Obviously, the signs will alternate. So we have negative 1 raised to the nth power. Let's see. When n is 1, I have negative. When n is 2, I have positive. When n is 3, I have negative. When n is 4, I have positive. Yes, that works. So now, how do I represent 2, 3, 4, 5, 6? Since it starts at 2, it's n plus 1. And now it is wise to check again. When n is 1, I have negative. 1 plus 1 is 2. That's correct. 2 plus 9, 11. I got the first term. Now when n is 2, I have positive. 2 plus 1 is 3, correct? 4 plus 9 is 13. 3. Negative, yes, it's negative. 3 plus 1 is 4. 6 plus 9, 15, and everything works. So that is the general term. Any questions?
If it was even, then what would the
What do you mean by even?
I'm just saying, like, as hypothetical.
Which part? What do you mean by even?
The
Oh, the denominator. Well, it depends on where it starts.
So if it's, let's say,
Normally, see, an even could be just 2n.
but if it's,
That's an even number. If it's even, they're all divisible by 2, right? Once you say even, you say even, everything is divisible by 2. So it could be 2n.
if
But
it
depends on where it
It
starts.
started at like 6, we do 2n plus 4,
2n plus 4.
and that's where we'd start. Okay.
But depends. You have to look at the pattern. Just one number is not going to. Okay, what about a negative 2 over 5 squared, negative 2 over 5 cubed, negative 2 over 5 to the 4th? I only ask here one question. Not to find a generic term. It's very easy to find a generic term. Is this a geometric sequence? And you could say, I don't know. The answer is I don't know. If I divide this by the previous term, or I divide this by the previous term, and I get the same answer, then yes. It's the common ratio. So if I divide this by this and I get 10, and I divide this by this and I get 10, then it's a geometric sequence. The common ratio is that number. So let's check. I don't really have to do that. It's very clear. I multiply this by something to get this, and by the same thing to get this, and by the same thing to get the next term. Can anyone tell us without even dividing, what is that common ratio? Common ratio is? Indeed, 1/5. So therefore is geometric.
Could you use this example to do the general term? With the general term?
It's very simple. It's just 5 to the n, right? Or n-1, depending on where you want to start. You can start at 2. But now what is more important, I would like to determine, we can determine the general term. Why not? But what I'm interested in is determining the sum of this infinite geometric sequence. It's a series, actually. And remember the formula for the sum of an infinite. So after we write it, so the sum is a1 over 1 minus r. And r in absolute value has to be smaller than 1. And it is, because it's 1/5. Otherwise, we cannot determine the sum. We say that the series does not converge. So we can't determine the sum. But in this case, we can. So let's determine the sum, and as well, as you said, also determine the general term. So the general term is, it's definitely -2/5 to some power, and that power will be n-1. But in this case, we should start, or we put n+1, and we start at 1. Or we put n-1, and we start at 2. So let's see what happens. Let's check a few terms to make sure. When n is 1, -2/5 squared. When n is 2, -2/5 cubed. When n is 3, -2/5 to the 4th, and so on and so on. So that's the general term. What will be A1? I know I have 4 minutes left, I know. What will be A1?
-2/5.
So A1 is -2/5 squared. Okay, so then how do I determine the sum? So the sum will be -2/5 squared divided by 1 minus 1/5. And let's see what we get as the sum of the infinite, and I will not forget to give you this formula. So this is -2/5 squared, and this is 4/5, so 5/4, and I simplify, and I simplify, and I get -1/10. How do we calculate something like this with a graphing calculator? Let's say from I equals 3 to 15, from 2I over I plus 3. How do I determine this with the graphing calculator? If you do not have that sum, you can use the software. Oh, you're not going to be here. If you don't have a calculator, which I don't, I have 2 calculators, one of them doesn't. So if you do not have a calculator that gives us the number here, just write this. When I is 3, 2 times 3 over 3 plus 3 plus, when I is 4, 2 times 4 over 4 plus 3 plus ... plus 2 times 15 over 15 plus 3. And do not calculate the sum. If you have a calculator that gives you this number, you do not have to present this. Just put everything in the calculator and give the sum. If you don't have a calculator, that's fine. So let me show you with the graphing calculator if you have this feature. If you don't, just write the first 2 terms and the last one with plus, plus, plus. So we have 3. So x equals 3. And to 15. And please remember, in parentheses, you have to put parentheses again, careful. So you have 2x, and then divide by, in parentheses again, x plus 3. And close the parenthesis, and another parenthesis for the whole fraction. And then when you press enter, you will get 18.729. If you do not have this, just write as I said, write the first 2 terms, dot, 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 the last term, and say, I don't have a calculator, I can calculate this. I don't expect you to do this by hand, of course not. No, no, no. I can't think of anything else. I can't think of anything else. I think we, yes, please.
So which formulas will be given in?
I will
test?
give, so you mean for the entire test?
No, for sequence. For sequence.
Oh, I will give you the finite sequence, which is 1 minus r to the n times a. So the other sum for the finite sequence is a1, 1 minus r to the n over 1 minus r, where r does not equal 1. And the other one is a1 over 1 minus r, with r being less than 1 in absolute value.
I'll switch it.
Just these two.
So one is for finite and.
Yes, this one, it has n, it's finite. This one doesn't have n, it's infinite. See, when n goes to infinite, this number will be 0. It's the same formula. But when n goes to infinite, this will be 0. And that's how you get this one. Because the requirement is that the absolute value of r is less than 1. So this will go to 0. So you see it's the same formula?
The question will be given in this format, like the sum sign, and then whatever the question is, 2i over 5 plus.
Say it again.
The question will be in this format.
Oh, what the question would be? Find the sum of the finite sequence or find the sum of the infinite sequence.
So how we will know like the sequence is finite or infinite?
Very good. Right? If you have infinite here, it must be this. If you don't have infinite and you have 15, it must be that. Infinite geometry. Very good question, actually. Thank you.